It was the future of flight, sleeker, faster, and more advanced than anything before or since. But supersonic passenger travel didn't just fail once, it failed twice. And the reason wasn't just money, it was engineering. In the post-World War II jet age, optimism soared with the space race and Cold War rivalries. Studies for supersonic travel kicked off in the UK as early as 1954, leading to a 1962 treaty between Britain and France for the Concorde, with initial costs pegged at £70 million, ballooning to over £1.68 billion in today's money. The first prototype flew from Toulouse on March 2, 1969. Meanwhile, the Soviets jumped in with the Tupolev Tu-144, approved in 1963, aimed for 5 prototypes in 4 years. It beat Concorde to the skies on December 31, 1968, from Zhukovsky Airport, going supersonic just months later on June 5, 1969. The engineering challenge? Breaking the sound barrier with paying passengers aboard. 2 visions emerged: the Concorde, a British-French marvel of precision and luxury, seating 92 to 128, and the Tupolev Tu-144, the Soviets' bold, rushed counterpunch, built by the Voronezh Aircraft Production Association, with 16 aircraft produced between 1967 and 1983. Fun fact, the Concorde's name was suggested by an 18-year-old, symbolizing excellence, England, Europe, and Entente Cordiale, complete with a spelling debate over that extra E. And if you're enjoying this dive into aviation history, make sure to subscribe for more stories like this. Aerodynamics demanded delta wings and slim bodies, but drag at Mach 2 was brutal. For Concorde, the ogiva delta wing maximized vortex lift for low speeds, inspired by engineers like Johanna Weber. The Tu-144 evolved to a double delta, with retractable mustache canards to cut landing speeds to 315 to 333 kilometers per hour. Heat was a killer. Noses tilted for landing visibility, fuselages stretched from friction. Concorde expanded by 300 millimeters in flight, with engineers wedging caps and gaps that formed. Built with high-diminium aluminum alloys, its skin hit 127 degrees Celsius, cooled by white paint, dropping temps by 6 to 11 degrees Celsius. Tu-144 used 15% titanium and non-metallics for 110 through 130 degrees Celsius skins, tested in chambers revealing fatigue cracks. Engines were beasts. Concorde's 4 Olympus 593 turbojets delivered 38,050 pound-force each with afterburners for takeoff only, controlled by digital processors, a passenger jet first. Tu-144's NK-144 turbofans guzzled fuel at 1.58 kilograms per hour, limiting range to 2,500 kilometers initially, upgraded to RD-36-51 for 5,330 kilometers, but still short of Concorde's 6,470 kilometers. Comfort? Sonic booms banned overland flights. Cabins were tight from fuel tanks. Concorde at 60,000 feet meant higher radiation monitored by radiometers, with descents if spiked. Tu-144 noise hit 90 to 95 decibels, so loud passengers passed notes. Its AC system was a constant roar, and early models had pilot ejection seats, a rarity for commercial planes. Disaster struck early. At the 1973 Paris Air Show, the Tu-144 broke apart on camera due to structural flaws from Soviet shortcuts and political rush. Cracks spread rapidly without arrest features, as seen in 1971 TS-AGI tests. It had entered freight service in 1975 between Moscow and Alma-Ata, but passenger flights in 1977 were a mess. Panels ajar, stuck trays, toilet failures on the inaugural run. Over 226 failures in 181 hours, including a 1978 alarm blaring for 75 minutes. Crews stuffed a pillow in it.
This plane will be carrying passengers across the Atlantic at more than twice the speed of sound. It is the Concorde, the only supersonic jet in commercial service.
All set, everybody? Ready? Okay, 3, 2, 1. Now?
Concorde lasted longer, entering service in 1976 on transatlantic routes, having times to 3.5 hours, even flying Queen Elizabeth II in 1977. But it battled rising fuel costs in the 1970s oil crisis, sonic boom route limits, and tiny passenger loads compared to jumbos like the 747. Incidents piled up. Rudder failures in 1989 and 1992, 57 tire issues by 2000. The 2000 Concorde crash was technical. A tire burst from runway debris led to fire, but it symbolized the end, grounding the fleet for a year with Kevlar tank upgrades. Economics doomed it. Costs per seat were sky high. Concorde's program hit 1.5 to 2 billion pounds by 1976. Engineering trade-offs meant speed sacrificed comfort, efficiency, and range. These were Cold War vanity projects, not viable businesses. Tu-144 flew just 102 commercial flights, only 55 with passengers. It wasn't just building the fastest plane, it was making speed affordable and safe. Neither side could crack that. Today, Boom Supersonic's Overture eyes Mach 1.7 for 60 to 80 seats, with 4,250-kilometer range, powered by Symphony engines. 130 orders from United and American, factory built in 2024, test flights in 2027. Their XB-1 hit Mach 1.122 in January 2025, the first private supersonic since Concorde. NASA's X-59 Quest, unveiled in 2024, cruises at Mach 1.42 with a quiet 75 decibel boom, using cameras for visibility. Ground tests in 2025 aim to lift overland bands by 2028. Can engineering make supersonic economic? Concorde and Tu-144 show what's possible, but also limits where physics, economics, and politics collide. It didn't fail because we couldn't do it. It failed because we couldn't do it sustainably. What do you think? Will supersonic travel soar again? Comment below. If you enjoyed this, subscribe and hit the bell for notifications.